Alright guys, I was asked to cover this question. This is homework question number 14 in chapter 2.1. So for the given function, they want you to do two things. First, find the equation of the secant line through the points where x is minus 3 and x equals minus 1. And the second one, part B, is find the equation of the tangent line when x has the first value, meaning find the tangent line when x is equal to minus 3, right? And this is the function we're talking about, x squared plus x. Okay, so before we even really start doing anything, we have to define some stuff. So the first definition, what is a secant line? So a secant line is a line that connects 2 points of a graph. So you pick any 2 points on a curve and you connect them, there you go, you have a secant line. So for instance, here's a picture. This blue thing is a curve, and I've created 2 points on it, and I've drawn a line through those 2 points. That is a secant line. So what is the difference between a secant line and a tangent line? Well, a tangent line touches the curve only at 1 point. Okay, so it looks something like this. It's a tangent line and it touches it only at 1 point. So for a secant line, how do you find the slope of a line like this? Well, we just do our normal slope equation, right? Rise over run. How do you find the slope of something like this, of a tangent line to a curve, is we have to take the derivative. So let's go ahead, let's do part A, and that's to find the secant line first. Okay, so first we got to know what points are on our graph. So if f of x equals x squared plus x, then find the equation of the secant line for x equals 3 and x equals minus 1. So if I plug minus 3 into our function x squared plus x, I get 6. This means that the point minus 3, 6 is on our graph. So I plugged in the first x. Now if I plug in the second x, which is minus 1, if I plug in minus 1 into our function, I get 0. This means that the point minus 1, 0 is also on our graph. So we have 2 points that are on our curve, and all they want us to do is connect them via a sum straight line. So this is what they want us to do. Our curve looks like this, x squared plus x. And these are the 2 points that we just located, A and B. And they want us to draw a line connecting the two. So this black line you see right here is our secant line. They want you to find the equation of this line. Hey, we've been doing that since last semester, so we're able to do this. Okay, the first thing I'm going to do, anytime I find the equation of a line, well, anytime I want to find the equation of a line, the first thing I want to do is find the slope of it. So I'm going to use regular rise over run here. So the slope equals y2 minus y1 divided by x2 minus x1. So then I have 6 minus 0 divided by minus 3 minus minus 1. So I'm using these 2 points that we've located, and I'm finding the slope. So it turns out that the slope is minus 3. So the slope of this secant line connecting these 2 points is negative 3. Okay, so of course a line has the form y equals mx plus b, and now we know that the slope is minus 3, so we can go ahead and fill that in. So what's the only other piece of information we need to know is the y-intercept b. So what I'm going to do is I'm going to pick either one of these 2 points that are on the line, pick any point that's on the line, but I know these 2 points are for sure on the line, and I'm going to plug them in for x and y. So I chose the point minus 1, 0, and using point minus 1, 0, I just solve for b. So I found out that b is equal to minus 3. Therefore, the equation of my secant line is y equals minus 3x minus 3. Okay, so that was very straightforward. They told us we have 2 points and just find the line that goes through both of them. That's all. Okay, so let's do the other one. So if we're given the same function, find the equation of the tangent line at x equals 3. So remember, the tangent line hits my graph at 1 point. So here is the point minus 3, 6, right? And this is the tangent line that hits it at that 1 point. So our goal is to find the equation of this line. And like I said earlier, whenever we find the equation of the line, the first thing you want to do is find the slope. We also said prior that the slope of the tangent line is given by the derivative. So let's go ahead and find the slope of the tangent line. So the slope of the tangent line at x equals minus 3 is given by the derivative as after you plug in minus 3. So if our function is x squared plus x, the derivative using the power rule is 2x plus 1, right? Let's use the power rule here, use the power rule here. You get 2x plus 1. So the slope of the tangent along the curve is given by this formula. But we want to know the slope at a certain point, which is minus 3. So what I'm going to do is I'm going to plug in minus 3 into this function. So if I plug in minus 3, I get 2 times minus 3 plus 1. And of course, that equals minus 5. So now we know the slope of that tangent line. So here's the equation of a line. The slope is now minus 5x plus b. All we have to do is now find the y-intercept. So what is the only point that we know that lies on this tangent line? Well, it's this one, minus 3, 6. So let's go ahead and use minus 3 and 6 as my x and y points here. So if I plug in minus 3 and 6, I'm able to find out b, which is minus 9. And so you guys can see it. And now that's it. I have the equation of my tangent line. Y equals minus 5x minus 9. All right, hopefully that helped.